Right now, you are sitting inside a giant invisible bubble. This isn't science fiction, it's just good old-fashioned science fact. Our planet, the Earth, is wrapped in a massive magnetic field. You can't see it, you can't touch it, and you certainly can't taste it, but it's there. It stretches out from the deep molten core of our world and extends far into space, acting like a protective shield. Think of it as Earth's personal bodyguard, a silent guardian that works around the clock, every single day, without ever asking for a thank you. Deep beneath our feet, thousands of kilometers down, is the Earth's core. The outer part of this core is a massive ball of scorching, hot liquid metal, mostly iron and nickel. Because the Earth is spinning, this liquid metal is constantly churning and sloshing around like soup in a pot that you're stirring really fast. This movement creates powerful electrical currents, and whenever you have electrical currents, you get a magnetic field. Our sun, the star that gives us light and warmth, also has a bit of a temper. It's constantly blowing out a powerful stream of charged particles in all directions. This isn't like a gentle summer breeze. It's a super fast, super hot wind called the solar wind. It's made of protons and electrons, tiny particles blasted away from the sun's surface at speeds of up to 400 kilometers per second. That's over 1,000,000 miles per hour. This is where our magnetic field steps up to the plate. It acts like a cosmic deflector shield on a starship. As the solar wind races towards us, it first encounters our magnetic field, the magnetosphere. The field is strong enough to divert the vast majority of these charged particles, forcing them to flow around our planet instead of slamming directly into it. To understand what a world without a magnetic field looks like, we don't need to rely solely on our imagination. We can just look next door, to our planetary neighbor Mars. Billions of years ago, scientists believe Mars was a much warmer and wetter world. It had a thick atmosphere, flowing rivers, and maybe even vast oceans. It also had a protective magnetic field, much like Earth's. But then, something went wrong. The Martian core cooled down and solidified. The geodynamo, the engine that powered its magnetic field, sputtered and died. Without its shield, Mars was left naked and exposed to the full, unrelenting fury of the solar wind. For millions upon millions of years, the solar wind has been blasting Mars directly, stripping away its atmosphere particle by particle. Let's get down to the nitty-gritty of what losing our magnetic shield would mean for our air. The process is called atmospheric escape, and it would happen a lot faster than you might think. Water vapor, H2O, would be broken apart by the harsh solar radiation into hydrogen and oxygen. The light hydrogen would escape almost instantly, and the oxygen would follow. As the solar wind erodes this blanket, the atmospheric pressure at the surface would begin to drop. Breathing would become more difficult. The weather patterns we know would be thrown into chaos. The sky itself would change color, eventually thinning to a pale, washed-out version of its former vibrant blue, before dimming into a perpetual twilight. In our modern world, we are utterly dependent on technology that is powered by electricity and guided by invisible signals. If the Earth's magnetic field disappeared, our entire technological civilization would be thrown into immediate and catastrophic chaos. The first and most significant victim would be our electrical power grids. When exposed to intense blasts of charged particles from the sun, these wires act like giant antennas, inducing massive uncontrolled electrical currents that overwhelm the system. Our skies are filled with thousands of satellites that we rely on for everything from GPS navigation to global communications. Without the magnetic field, they would be constantly bombarded by high-energy particles. Their sensitive electronics would be fried. This means no more GPS. Your phone's map app would be useless. Global communication would cease. You wouldn't be able to make an international phone call or even process a credit card transaction. For thousands of years, humans have navigated using the magnetic compass. Without a magnetic field, the needle of every compass on the planet would spin aimlessly. The concept of a fixed magnetic north would cease to exist. But humans aren't the only ones who use this planetary guidance system. A huge number of animals have a built-in biological compass called magnetoreception. Migratory birds would become hopelessly lost, unable to find their breeding or feeding grounds. Sea turtles would wander the oceans aimlessly, their ancient pilgrimage routes erased. The intricate dance of global migration, a rhythm that has played out for millions of years, would fall silent. This would trigger a cascade of ecological disasters, as ecosystems that depend on the arrival of migratory species would be thrown into disarray. One of the most breathtaking natural spectacles on Earth is the aurora borealis and aurora australis, the northern and southern lights. These shimmering curtains of light are a direct and beautiful consequence of our magnetic field at work. When the sun's solar wind hits our magnetosphere, some charged particles are caught by the magnetic field lines and funneled down towards the magnetic poles. As these particles slam into atoms in our upper atmosphere, they cause them to glow. With no field lines to capture and channel these solar particles towards the poles, the auroras would vanish. The polar skies would fall dark and silent, losing their celestial dance forever. The energy that once created beautiful, localized displays at the poles would now be spread across the entire planet. The beautiful dancing auroras would be replaced by a faint planetary death glow. Our magnetic field doesn't just protect us from the sun, it also provides a crucial shield against galactic cosmic rays, high-speed atomic fragments that have been blasted across the universe by distant cataclysmic events like supernova explosions. If our magnetic shield were to disappear, the surface of our planet would be constantly bombarded by this high-energy radiation. The background radiation level would skyrocket to levels far exceeding what is considered safe for astronauts in space. For humans and other animals, this would lead to a dramatic increase in health risks. Radiation exposure causes DNA damage, which can lead to cancer, cataracts, and genetic mutations. Life outdoors would become incredibly hazardous. Perhaps humans would need to build underground cities or line their homes with thick layers of lead or concrete to shield themselves from the constant cosmic ray shower. After painting such a grim picture, it's important to remember that our magnetic shield is still here, working just fine. Organizations like NASA and ESA have dedicated missions, like the Swarm satellite constellation, that are mapping our magnetic field with unprecedented precision. By monitoring the field's strength and the movement of the magnetic poles, they can build better models to forecast future changes and give us an early warning if significant shifts are on the horizon. Understanding the dynamics of our magnetic field allows us to prepare. If the field were to weaken significantly, we could develop more robust technologies. We could design satellites with better radiation shielding, create more resilient power grids. So, while the thought of losing our magnetic shield is shocking, it should also fill us with wonder and appreciation for the invisible forces that protect us. The Earth has taken care of life for billions of years, and by studying its systems we can learn how to be better caretakers of our only home in the universe.